Set B question number 53. The question says, let S equal to set of values of t such that t belongs to a set of real numbers. And how do you define t? F of x is a function in x and it is not differentiable at t. So set S consists of all those values of t at which this given function f of x is not differentiable. And we have to find out what will be this set equal to. You can look at the option. For example, option number 1 says set will include only one value, that is pi. Option number 2 says it will include two values 0, pi, and so on. So basically, by looking at all the four options, one thing is clear, that we have to check the differentiability of the given function at 0 and pi. If it is not differentiable at any of those points, then those will be included in the set. If it is differentiable at both the points, then the set will be an empty set. So let us do this question. It becomes very straightforward question once we know what exactly we have to do. So we will check the differentiability. How do you check the differentiability? By calculating left hand derivative and right hand derivative. Let us start with the left hand derivative first. The formula or the definition of left hand derivative is nothing but limit h tends to 0 minus f of x plus h minus f of x upon h. Now this will be nothing but limit h tends to 0 minus. We are first checking the differentiability at, let's say, x equal to 0. So because x is equal to 0, we will consider f of x plus h at x equal to 0, which will become f of h minus f of 0. Now you can see that what is f of 0? If I put x equal to 0 in the function, sine of 0 will become 0. So f of 0 is simply 0 upon h. Now let us see what exactly is this equal to. Limit h tends to 0 minus f of h will be nothing but this whole function in which x will be replaced by h. So let me do it. This will become mod h minus pi mod h minus 1 into sine of mod h, and this will be divided by h. Now this will further become limit h tends to 0 minus mod of h minus pi. So if I keep this as it is, further I get e power, because h is tending to 0 minus, that means h is tending to 0 from the left hand side. So mod h will be nothing but minus h minus 1 and mod h minus h. So sine of minus h will be minus sine h. So I'll keep that minus sign outside and I will take denominator h with sine h. Now let me apply limit on each and every term. So this will become h is tending to 0 minus, so this will become 0 minus pi, that's minus pi, but mod of minus pi is pi with a minus sign, so minus pi. Because h is tending to 0 minus, e power minus h will tend to e power 0, which is 1. 1 minus 1 is what we get here. And we know that sin h by h will tend to 1. So this whole limit becomes equal to 0. Now let us talk about what happens when I consider for the same point x equal to 0 the right hand side limit. Sorry, the right hand side derivative. The right hand side derivative will be equal to limit h tends to 0 plus f of x plus h minus f of x upon h. Now this will further be equal to limit h tends to 0 plus, because I have considered point x equal to 0, I'll consider f of h here. F of x at x equal to 0 will be nothing but, you can see 0 again, because sine of 0 will be 0, so this is 0 upon h. So basically what we get is limit h tends to 0 plus f of h upon h. Now you can see that this will be very much similar to whatever we have already done. The only difference will be, instead of minus h, we will replace this time mod h with plus h. But what difference will it make? Sin h by h will still tend to 1. E power h will tend to e power 0, which will still be 1. And 1 minus 1 will still give us 0. The only difference will be this minus sign will be absent this time. But the answer will still be 0, and hence we conclude that without even having to solve, we say that the right hand derivative is equal to 0, and therefore right hand derivative is equal to left hand derivative. LHD is equal to RHD, and we conclude that the given function is differentiable at x equal to 0. Let us now discuss the differentiability for x equal to pi. So for that, I will consider left hand derivative first, which is limit h tends to 0 minus f of x plus h, but x is pi, so pi plus h minus f of x, which is f of pi, upon h. Now this will be equal to limit h tends to 0 minus f of pi plus h will be what? F of pi plus h will be, x will be replaced with pi plus h minus pi. So pi will cancel out. We will have mod of h into e power mod x will be nothing but mod of pi plus h minus 1, and further sine mod x, that will be nothing but sine of, this will be pi plus h. Now this will be divided by h. F of pi will be nothing but sine of pi, that will be equal to 0. This will be equal to limit h tends to 0 minus mod h will be nothing but minus h, because h is tending to 0 from the left hand side. I will write h, denominator h right here. This will be e power mod pi plus h can be written as pi plus h simply because pi is greater than h for sure, minus 1, and sine of pi plus h will be nothing but minus sine h. So that minus and this minus will become plus. We can see that h will cancel out, and because h is tending to 0, sine h will tend to 0, so left hand side derivative becomes equal to 0. Now if I find out right hand side derivative, then it will be nothing but limit h tends to 0 plus f of pi plus h. F of pi plus h, let us see what will it turn out to be. Minus f of pi, we have already seen f of pi is 0, so I will divide it by h. Now this will further be equal to limit h tends to 0 plus, this time we can see that mod h will simply be, because f of pi plus h is the same thing we are going to get, mod h will be nothing but simply h here, because h is tending to 0 from the right hand side, divided by h. This will be e power pi plus h as it is, minus 1. And further sine of pi plus h will be nothing but minus sine h, so there will be a minus sign here. H will again cancel out, and you can see that because h is tending to 0, sine h will tend to 0. So this particular term, even though it is non-zero, but it gets multiplied by a limit tending to 0, so the overall value of the right hand derivative also becomes 0. So we conclude that left hand derivative is equal to right hand derivative, and therefore the function is differentiable at x equal to pi as well. So we finally conclude that function is differentiable at x equal to 0 as well as x equal to pi, and hence we say that the correct answer is option number 3. That means there is not a single value of t at which the function is not differentiable.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.